Welcome all. I am going to discuss about a Matlab software which is useful for the electrical engineering students. So here we go to the Matlab software console. Here we can see the front panel of the Matlab software window. Here is the home. We can plots, plots, multi plots, area, bar, scatter, pi, etc. Applications. Here are some applications we can see which are pre-installed. Here go to home page. Script. Script used for the programming. Here you can type the program and execute the program. You can see the output. Today we are going to see about the simulink tool, which is useful for the students to create circuit and models to get the desired output from the input uh, for any value which can they decide about. So you can open the Simulink. It is the black model. With blank model, you can create circuit and models. Here is a simulation window. Here is the fundamental tools library, also known as library browser. Here is a Simulink. We can see the commonly used blocks, continuous signal, dashboard, etc. Here we can discuss about the Simscape, Simscape power systems. Here there for the electrical students. Here you can see about the control system toolbox. Here you can see the filters, LPV system, etc. Here is a LT system, linear time invariant system. We can see Simscape. Here are the foundation library with a primary tools. You can see here's a electronics. You can activators and drivers, ICs, passive devices, additional components also you can see, which I already used in this Spice simulations tools. Here like a neural networks is useful for the artificial intelligence and machine learning. Fuzzy logic toolbox which is useful for the facts controller. Now we can see about the electric. Now we can see about the electrical toolbox. Searching. Here's a Schemscape, which is a tool under the Simulink window. You can see about electrical elements, electrical sensors, sources. Um, the blue color shade for the components, which indicates about the components under the low power applications, which is useful for the electronics design circuit. Here, the black color indicates shades of the component indicates of the high power applications like 220 volt, etc. Here, here such components like sister blue color indicates about the 5 volt, about 24 volt, etc. This section and this section are not able to interconnect, which gives a error message. Here's the electrical elements, capacitor, diode, reference, etc. Rotational, electromechanical converter, etc. Now we can demonstrate about such simple circuit. We got some resistive load and simulation plate. Here we can see the difference of the color of the components. The blue color indicates a low power application. Red color indicates of the high power applications. System. Here we can see the resistor which is in shade of blue color, which means of low power applications such like that DC source. Next we see about the DC source. Some error is here. It we see let's see another example. Now the power electronics circuit can be designed now. So we can see the major difference between this AC voltage source and this AC voltage source. The main difference is about the power application. Here we can see the blue color shade is about the very low power applications, is for the high power application. Let's see first low power application such as the off a rectifier circuit. You connected. Next is voltage measurement. Now we can simulate the circuit. Here is the logic analyzer for that. logic analyzer for the getting output. Let's just minimize it. First, select the circuit. Simulation data inspector, which allows like CRO probe the real-time visualization of the outputs. Log selected signals. It is the help window which can use it for reference. So here are the some things which useful for power electronics. Let's move to the some reference. Here is Simulink Getting Started Guide, which is officially given by the Matlab website. Here we can see some reference data on how to work with simulation. Here is the product description. So, what is about Simulink and the product based upon the simulation and model based design? Here are the key features: graphical editor, libraries, simulation engine, scopes, project and data management, etc. Next is the model based design. For a bulky circuit, we can create a model such as like that subsystem or the, and creating a port for the input and output. We can minimize the size of the circuit diagram. Model based design allows a common design environment applicable for input and output ports. Link designs identify correct errors continuously for identifying errors which tedious for the designer to where is the error is located. By creating models, easy for them to detect the errors and correct easily. Refine algorithms, which means constant methodology for the all the models in the model. Here is a flow diagram for the data workflow in the Simulink. Here you can see. So, what are the requirements of the system? System level design, subsystem design. By using subsystem design, we can minimize the size of the circuit by mentioning its input and outputs, system specification, high level design, low level design. We can specify the system specification by high level design and low level design based on the size of the circuit or the based on application. We can decide whether it is a high level or low level design. Subsystem integration and test. For the large circuit, we can create a subsystem. We can integrate with the other subsystem by input and output port. By simulating separately, we can verify whether specified subsystem is operating or not. System integration means integrate all the subsystem and testing it by giving its input and verifying its output. Complete integration and test, which means whether we can go to the PCB design or the uh, PCB design or the some simple breadboard design, etc. So in this given reference material, they are materials and system definition and layout, model and validity system, design a system and simulating, organize large modeling project, which are readily available in the MATLAB website. External website simulating overview. We can what are the facilities available in simulating, etc. are given. Model based design is a good tool for the Model design is a good tool for the engineers to create a more number of subsystem which easily minimize the overall circuit, etc. So here are the basic introduction about the MATLAB, etc. And thank you.